Hi, we're from the Neuroergonomics Laboratory at Texas A&M University, and we are presenting Team Trust Dynamics in Multi-Human Robot Teams. My name is Diane Lee.
Hi, I'm Charlotte Koch, and our other co-authors on this presentation are Thomas Fo, who's in the audience with us, Malik Rawashde, Akash Yadav, and Dr. Ranjana Mehta. So in 2021, the average firefighter casualty was 75 fires, for which So we're exploring the possibility of adding robots to a emergency response situation. Robots are precise and have advanced sensors and are better at navigation and mapping. So this reduces the response and recovery time in such high pressure situations where the first 48 hours in a casualty are very critical. Some background on the terms that we use in our presentation is trust and human autonomy team. Trust is defined as the attitude that an agent will help achieve an individual's goals in a situation characterized by uncertainty and vulnerability. And human autonomy team is defined as the interdependence in activity and outcomes in one or more autonomous agents, where each human and autonomous agent have distinct roles and work together to achieve a common goal. Our objectives in our study are to gain insight into individual and team trust in all human and multi-human robot teams, to compare their performances and assess the efficacy and hyperscanning of multimodal synchrons.
So we recruited 16 participants to form 8 teams, and out of those teams, 4 were male-male, 1 was female-female, and 3 were male-female. The average age of these participants was 23.38 years, and the average time these participants spent playing video games was 4.73 hours per week. This is a protocol timeline of our experiment. Before the experiment began, the participants were asked to complete a familiarization task, including 2 engagement activities: introducing themselves and planning a picnic. There were 2 conditions: human-human-human and human-human-robot, which were counterbalanced, each including 5 trials and 3 minutes for each trial. After each trial, participants were asked to fill out survey questions to measure factors such as trust and performance. The virtual environment was created in Unity 3D in a game format. The participants were able to use WASD keys to move around the environment, and the participants were tasked with finding as many victims as they could in each trial. This was created to depict a search and rescue scenario. The right figure shows the laboratory setup of the experiment and how the participants are positioned. Participants were bioinstrumented with F meters and ECG. There are 3 roles in this experiment. Human 1 always assumed the role of the mission specialist, who coordinated with team members and led the team. Human 2 always assumed the role of the safety officer, who monitored NOx levels of low, medium, and high to ensure team safety. Human 3 and the robot always followed the same behavior of the navigator, who had guided the team by giving directions to locate victims. Human 1 and Human 2 were always played by participant 1 and 2, while Human 3 and the robot was played by a manipulated human. In our case, we used an experimenter who's sitting right there, Mr. Thomas. The participants were all under the impression that the third human was just another participant and that the robot was a fully autonomous agent. This manipulation was implemented for better control and to reduce impact of the confounding variable. In terms of the robot, the Wizard of Oz approach was used, where the experimenter controlled the robot behind the veil. There were 8 pre-recorded responses to be able to communicate with Human 1 and Human 2. This entire setup was designed in consultation with Texas A&M Engineering Extension Services, which are internationally recognized leaders in training emergency responders.
The data that we analyzed and recorded was heart activity using an electrocardiogram, and we extracted measures such as SDNN, standard deviation of NN intervals, and mean heart rate. We also analyzed cardiac synchrony, for which we extracted measures such as percentage of determinism and percentage of recurrence. We also recorded brain activity using FNIRS, which stands for Functional Near Infrared Spectroscopy. We had 8 sources and 8 detectors, and the channel placements were right and left prefrontal cortex and right and left temporal parietal junction. We also analyzed performance by analyzing the combined distance traveled by human 1 and human 2 and the mean time they took to locate the first victim. We also took subjective responses where we had the participants complete a set of 5 questions to capture the trust between dyads on a 7-point scale. So this is our FNIRS processing pipeline. We start off with the raw FNIRS data collected from 18 channels. We use a modified Beer-Lambert law to convert the light intensity to oxyhemoglobin concentration. We then proceed to filter it using frequency filtering and wavelet filtering. We use motion artifact correction to correct the spikes in our data that are caused due to rapid head movements. We extract two HBO time series, one from participant 1 and the second from participant 2, and then we use wavelet transform coherence to extract a phase log behavior where frequency is the y-axis and x-axis is the time. This is our HRV processing pipeline. We start off with the raw ECG data that we filter using bandpass filter and then extract R peaks, which we then analyze using CRQA analysis, which is cross-reference quantification analysis, and extract percentage of determinism and percentage of reference.
So we found that teams perform more efficiently in terms of distance of meters over victims in the human-human robot condition compared to the all-human condition. But we saw that teams were able to locate the first victim faster in the human-human condition as compared to the human-human robot condition. From the results of the 1-point surveys, we saw that team trust was significantly higher in an all-human team, and the trust in a human navigator was significantly higher than a robot navigator, and dyad trust remained comparable between both conditions. So this animated figure is going to show the neural synchrony between human 1 and human 2 across both conditions. So these values denote interbrain synchrony, where higher values denote greater synchrony. So we saw that neural synchrony significantly increased in the LTPJ region from the all-human condition to the human-human robot condition. Saw that neural synchrony remained comparable across both conditions in the prefrontal cortex, and similarly to the LTPJ region, neural synchrony significantly increased in the RTPJ region.
We analyzed SDNN, standard deviation of NN intervals, and the mean heart rate on individual participants. SDNN essentially shows us how dissimilar the heartbeats are, and a higher SDNN and mean heart rate is associated with more stress and fatigue. HRV features measured for both human 1 and human 2 individually were comparable across conditions. We analyzed cardiac synchrony by analyzing percentage of determinism and percentage of recurrence. Percentage of determinism essentially shows us how long each synchrony persists between 2 time series, and percentage of recurrence shows us the overall stability of the synchrony between the 2 time series, and synchrony measures between human 1 and human 2 dyads were comparable across conditions.
So a study done by Hall Munson observed greater neurosynchrony in a 2-person human team compared to human-human robot. Our results deviated from their findings, where we saw greater neurosynchrony in human-human robot team compared to a 3-person human team. We suspect that humans employed complex joint cognition to work with the robots. We saw interbrain synchrony was higher in the TPJ regions, where these regions are implicated in teamwork, interpersonal behavioral coordination, and social cognitive processes. Saw synchrony in the prefrontal cortex remained comparable across conditions. Dyad trust remained intact between conditions, and human team members exhibited comparable individual physiological responses. These are references, and thank you.